Hello, today we're going to be doing exact change, all right? That's the project we're doing. The examples from freeCodeCamp. It's our advanced algorithm scripting challenge. Today what we need to do is we're going to be looking at an array of simple objects, okay? Each object has one key value pair. We need to be able to iterate through this array of objects and compare it with another object, all right? And that's sort of the logic of what we have to do today. So I want to take you through some things we need to understand, some tools we're going to use. Then I'll walk you through logic, and then we're going to try to code this thing. So let's go ahead and I'll share my screen and first take a look at some of the tools we're going to be using today. All right, so here's the setup. We're going to start off with using this right here. All right, and we have the global object. All right, so an object constructor creates an object wrapper. All right, so that's what we're talking about. All I'm talking about here is global object. So when you click over here, global object, this is what you're taking to. And it starts talking about the properties of an object, the length, all right, different methods you can use on your object. Look, all these things we haven't gone through yet, huh? But there's a lot that's there. And just like a variable has a scope, notice that my function is right here, and I've created or generated this object here. And notice it's a var money, and this money is just all the different denominations of money that we can have in a cash register. Now, also, I've commented out what I have down here, which is an example that I've been using. So this is the example of a till in a register. All right. For example, in pennies, you have $1.01 in pennies and $2.05 in nickels. But what we need to do is we need to be able to check the value of a nickel to see what a nickel is, and then see how much of it we have. And then we're going to get into the logic a little bit later on. So since I'm going to be using this, I'm generally going to use this in a larger program. So you're going to have a global object for money that you can then use locally to check against something like the till of a cash register. And the way we're going to be iterating through these arrays is we're going to be using the reduce method. Now, the reduce method applies a function against an accumulator, all right, from left to right. And notice that we have a function. And we've done this before, but we have an accumulator where we start from. The current value, all right, or what we're going to be doing is say we're going to be adding things together or concatenating this together. All right, that's the current value we're on, or the next value in the array that we're doing something to. So I think I'll be using that syntax next. I've seen somebody else use it, and it actually makes a whole lot of sense, at least for the workflow that we're doing. And we also have the current index number. So again, we're going to keep the current index here. And what we haven't done, we haven't really talked about here, you can also bring in an array, all right, which is what you're going to be talking about. So if you want like array dot length, that kind of thing. But what we also have is this optional initial value. And if you notice, I think maybe in our last algorithm challenges, we were talking about different methods that return a new array. Well, reduce is not going to return a new array. It's going to reduce a single array. If we want to use dot notation and add another function onto this, which we are going to want to do, what we need to do in the beginning here is we need to go ahead and give ourselves an initial value, which is going to allow us to add something to it or fix our math here. Because remember, dollars and cents, we're only going down to 2 decimal places. So in order to do that, I actually found what someone did was pretty clever. We started off with a starting value, which allowed us to add in the 2 fixed, which allows us all of our math to get rounded to 2 decimal places, which works out really nicely. So that's what we're going to be using that for. So try to remember that when we get there. We're also going to need this reverse, and reverse just reverses an array. Now notice we're going to be giving an array of simple objects, key value pairs, right? So this is pretty simple. So we have, name 100, value 100. Okay, so it's simple. Well, there's two things in here, the name and the value. So key name, and here's 100, and then the value is what this represents within 2 decimal places of a $100 bill. Same thing with a penny, 0.01. So we have these simple objects, all right, key value, and we're going to need to reverse an array. because this is an array, I want to iterate through this from the top to the bottom, but the way I'm going to do my math. However, if you notice, my example here is still, 100 at the top is the first thing, but given our example down here, and given all the examples here, they start off with penny, nickel, dime, quarter, so on and so forth. Notice that even if there are no values here, so like nickel 0, they're still going to give us this nickel. So the length of this array that I have for money that I've pre-described is still going to be the same length as they're going to give me in here, although some of these values will just be 0. So we have to make sure that I'm going to be using this array in my global money object to match up to the array that they're going to give me. So I need to make sure I have that in descending order, whereas they give it to me in ascending order. So we're going to have to reverse the array that they give us. The next problem I had was with some math. And look, it's Stack Overflow answers. What did I do? Simple. How do I round at most to 2 decimal places? All right, so I don't get like funny math. And what I found was this right here. And this little answer seems to work pretty well. And no matter where you click on or search the internet, you end up here. Math round. But what does a round do? And why are you multiplying and dividing by 100? Essentially, what math round does is gives us a whole number, a nice, good way to round, okay? However, what happens is it's a whole number. We want 2 decimal places. So if we multiply this whole thing by 100 and then round it, all right, that's going to move the decimal point over 2 places, right? Meaning that 2 decimal places is now a whole number. And then when we divide it back down, once we're done rounding, okay, it's going to move that decimal place back to where we want it. And again, just a simple, Google, how are people doing this? And that's how you could find, simple answers like this when you get stuck. Stack Overflow, here's the MDN. And that's really how we found it. Thought that was a neat way to show you. So those are basically most of the tools that we're going to be using. We're also going to be pushing some values and doing some simple math. But at this point, you should be well versed in that. So let's move on to some of our logic. And let's try to explain what we are going to do. So here is the problem that I have here, where we are given the price, the cash, and the cash in drawer. So the price, all right, if you read through this, the price is the price of whatever we're buying, all right? The payment is the second argument, which is the cash the customer gives us. All right, so this is the price of the object. This is the cash the customer is giving us. And then we have the cash in drawer, which is going to be our till. Okay, so what do we want to do here? We need to be able to compare. If someone buys something and, for example, it's $19.50 and they give you $20, right? You want to give them change. Most likely you're not going to give them 50 pennies, all right? You're going to give them 2 quarters. You're going to give them the largest denominations possible first, all right? Which means that we iterate through in our minds. We're saying, okay, can I give them change in a $100 bill? No. Can I give them change in a 20? No. How about a 10? No. No. How about a dollar? Oh, no, I can't give them a dollar. All right, so that means I got to go down to a quarter, right? Because the change is less than a quarter. $1 is more than the 50 cents that I need. 1/4 is smaller than the 50 cents that I need. So I'm going to need some amount of quarters. So if I give them 1/4, okay, then the 50 cents that I owe them, all right, is now going to be 25 cents. So how about if I give them 2 quarters? Okay, now I owe them no more cents. Now we are satisfied, and then we are done. Okay, and that's what we're going to do. However, we have an issue here. What happens when, let's just look over here. In this example, we have $4.25 in quarters. What we need to do is, as we give them a quarter, we know we need to give them a quarter now. We also have to decrement or subtract that value from our quarters over here. So I need to take this value and subtract it from the till I have in the drawer. What happens if I only had 1/4 in the drawer? If I didn't have 4.25 but only 0.25 in my drawer? Next, well, I would have to give them 1/4, all right, and then subtract that quarter. Now I'd have $0 in quarters, and I still have 25 cents to give them. So how would I do that? Well, I'd go down to the next denomination and take a look at dimes. Dimes are only 10 cents. So then I would give them 1 dime. I would be left with 15 cents. Subtract 10 from here. I'd have $3 in dimes. Next, I would give them another dime. There'd be 5 cents I owe them still, but let's remember to take that dime out of the drawer. Now I have $2.90 in dimes. I still have dimes left. I still owe them 5 cents, so I cannot give them another dime because a dime is too large. So now I have to go down to my next value and then look at a nickel. Do I have enough nickels? Yes, I do. Give them a nickel. Now they have enough change. And remember to decrement my till because now I have only $2 in nickels. All right? So that is going to be our logic here. Hopefully that makes sense. We have to make sure that our money is also in our descending order first, and then we can iterate through and see if the change value is enough to give them a dollar or a quarter or whatever. And then we also have to make sure we have enough of that money in the drawer at the same time. So logically, how are we going to go about doing this? Well, the first thing that we're going to have to do, they already give us this var change here, which is great. So we know we need to figure out the change. Well, the change is going to be pretty simple because it's just going to be the cash minus the price. Okay. And this here we have cash is 20, the price is 19.50. All right, we owe them 50 cents. Okay. I also want to take a look at something else here. I want to be able to know what the total cash in drawer is. A simple way to know if we have enough cash is to just add up all of these values. So I can perform a simple check in the very beginning. If I know that I owe somebody $90 in change because they wanted to pay with a $100 bill and I only have 220s and some change in the drawer, I know right away that I don't have to go through any sort of math or iterating through arrays. I know right off the bat that that there's going to be insufficient funds, all right, which is what they want us to show. See, like insufficient funds. So let's just give them insufficient funds right off the bat when we do that. So in order to do this, I need to know what the total of the cash in the drawer is, okay, or the total till. So I will just call this till for the total till. And all the till is going to be is I'm just going to take the cash in drawer, right? The CID or cash in drawer, and we can just call the reduce method on it. CID, call the reduce method on it. Now this is going to be a simple reduce, all right, where we're going to have an accumulator, and I can return this same array. I'm not manipulating anything else. All I really care about is the total amount of cash, and since we're going to be adding with reduce, remember we can add all the values in an array using the reduce method, and it is down here somewhere, right here, return a plus b. All right, now a is going to be our accumulator, which starts out as nothing in this array, but since my value in my array, if you notice, here's my object, all right, and so my object here, I really don't want this initial value here. I want to really talk about adding in the value being 100. I don't want to add in this name, all right, because I can't really add with names. I'm going to get an error. So I want to make sure I'm grabbing the actual value here, all right? And again, I want the value of the value. If it's a key value pair, I know it's a key value pair, so I have a key name value and a value of 100. But again, that's just what I used when I found this before, but it's pretty simple, all right? So here we go. So let's take a look at this. You could also have gone through and did just like the 20 and 60, but this just kind of spelled it out a lot easier when I actually figured this out, and I've found some help with this. So let's go ahead and reduce this. And again, reduce takes in an anonymous function. So again, since we don't have to use that function again, we could just say function. All right, and then A and B, and again, this comes right off of how we're going to add this stuff together. A and B, and then we need a function here where we just say A plus B. Okay, and I need to return A plus B. All right, now we know we're going to get an error because the accumulator is just where we're going to start. So we're going to say, so it's going to start as nothing, and we're going to add in the first thing to it. All right, and if you notice here that when we take a look at our 100 and then the value of that 100 here, if we're looking at the cache and drawer, it's an array of subarrays here. So it's a 2D array, whereas this is a global object, all right, which we've defined. So we can iterate through using the name and then the value. Here is just a 2D array. All right, I don't want to grab this first thing here, remember? I want to grab the value of that, okay? So if this is the A is going to be nothing, right, to start off with, and the B is going to be this whole chunk, this 100 comma, and then your actual value. I want to grab this piece right in here, just that 100 of this 2D array. So since I don't want to grab the 0th position of this 2D array, I want to grab the first position of this 2D array. All right, so I'm going to go like that. Right. Something else to note here. We have to do some math to this, and I only want to have 2 decimal places here, and I want it to be given that way, not with a string of zeros at the end. So I want to call be fixed on this, and I only want 2 decimal places. But we're going to get an error if we try to run this, right? Because your reduce here is not going to return a new array. Yet, if I give this a decimal for a starting position, okay, so my A is actually going to be my start, is going to be 0.0, all right, for my accumulator, that is going to return a new array for me, which is going to work out nicely if I remember to end that sentence and not have a syntax error. All right, so again, I just generated a new array with this. All right, so I have a variable change and a variable till, and all I did with till is I just reduced all this down and got the till of the drawer, the total amount of cash in the drawer, all right, the value of that total till that you have in that drawer. And what that's going to allow me to do is just to do a quick step and just solve a very simple problem that says, do I have enough cash in there? Don't worry about the bills. If your till is insufficient for the change, okay? So basically, if the change is more than the till, remember change and till I just described here. So overall, if the change is more than the till, I want to do something. I want to return just this string. And what string do they want to see? They want to see insufficient funds. I'm going to copy and paste that just to make sure I don't have any syntax errors when I write that. That's exactly what they want to see. All right. However, if I know that the change is exactly the same, so I know that there's 50 cents and I have 50 cents in the drawer, no matter what the denomination is, all right, if I know that they need 50 cents and I have 50 cents, I know I can make 50 cents out of the change that I have. Okay, so I'm going to use this else if, right? Because if I just have an else, if it's not insufficient funds, it's just going to jump to that else, and that'll be it. So I'm either going to get insufficient funds or closed. I only want this as an else if. Else if till equals the change. Okay, the till equals the change. Automatically know that that's going to be closed. Closed. All right. There we go. So that's the simplest thing to do. If there's not enough money at all right, insufficient funds. If I know it's exactly the same as I have in the drawer, give them everything that's in the drawer. Don't even have to count it. Nice and easy. All right. That's an easy problem to solve. And that's what this whole chunk is here doing. All right. I'm also going to be using this change to do something with a little bit later on. All right. So let's take a look at now. I have more money like this one, like this example here. then I have change, and I need to figure out how to pay this person back. The first thing we need to do is take this 2D array and invert it so we're in descending order. And just like I showed you before, we're just going to use this. This array is a 2D array. It's the CID, or cache in drawer. So all I'm going to do is take my cache in drawer, and I'm going to reverse it. Not reverse, English skills aren't so good this morning. Reverse it. All right, and now I have it looking like this up here with the 100 at the top. All right, this is all making sense so far. All righty, so now I don't want to return my change. This is just some of the default code that was in there. So let's see. I reversed it, and now I want to do something else. I need a result. All right, I'm going to return a resulting array. All right, and since I'm going to return this array, this array is going to have something just like this back. And let's just see, here we go. And this is going to be another 2D array with only the value I needed. So I don't want to return, I need 0 $100 bills and 0 20s. I only want to know in this case right here, all right, that I need a quarter, and the value of that quarter is going to be 50 cents. Now, I could take it another step and have a counter that tells me how many times I go through this loop of giving them a quarter each time. I could give them the number of quarters, but we're not asked to do that here. Just ask for the total, and that's it. Assuming that our teller can do math, which is not always a good assumption. However, anyway, we don't have to worry about that. So I know this is going to be an array. So all I'm going to do is I'm going to take all of this money here that I have, and I am going to reduce this down. Okay, and I'm going to reduce it down into an array. So how do you think we're going to go about doing that? Well, this is going to be kind of interesting here. What I'm doing right now is I am going through actually on my other computer, and I am taking a look at what I want here. Reason being is I want to double check one thing before I say it and then look like an idiot. Yes, okay. So I can do this. All right, I'm going to try something. I had a little idea here that might work. Anyway, so what I want to do is I'm just going to have another result, and this result is going to be an array. And notice that since this is an object, what I can do is I can actually push the value by calling value using dot notation. All right, or I can use the name to get this name. Also note that these things line up. So I have an array of objects and an array of arrays. So this main money array in the 0th position is an object that has something that I can call with name and value, whereas this 2D array just has a 0 and a first position. All right, so notice that's the difference between an object and an array. An object, each thing inside not just has a 0 and a 1, all right, here, but it has a descriptor, a key. So the key here is name, the key there is value. And it has the value. This value is the string 100, and this is the value 100. So I can actually separate these by calling this as the 0th position, or iterate through this array and then look at what this is, compare it to the name, look at what this is, compare it to the value. Then I can do math with this value, which is what I want to do as I subtract it like I showed you in the beginning. So I'm going to have this result, and let's kind of get into this. What does this actually look like? All right, I'm going to take this, and I'm going to access this money here, right, which is this global object. So I'm going to take, why did that turn green? Money dot reduce, and again, I'm going to reduce this. And when we reduce, we need to use our function. Right? And when we do this, we're going to have remember we have an accumulator. going back up here. We have a current value and a current index, okay? And I'm going to use all three of these, okay? And now the current value, I actually saw somebody use the next value that better describes it, because this is where we are, the accumulator, and what we're going to be adding next is going to be the next thing from that array. And I really like the way that person described this. And then the index is the index value. So in this array, 0, 0, 1, 1, 2, 2. And see how they all line up here. And we've already done that. And I've showed it to you visually. And the index. So here we go. Let's do some stuff. All right, so what stuff am I talking about? Well, I'm going to end this sentence here. I'm also going to, I want to return an array, all right, a 2D array. So if you notice in here, the quarter is in a 2D array. If I don't give myself a starting empty array, I would only get a single array back. And they want this value back in a 2D array because that's how they gave it to us. So I have to actually give myself a starting point of an empty array to push all these arrays into. So let's do that, make sure that's nice and clear. So we want to start off and say if the change owed is greater than or equal to the value of the current denomination. So here I needed to give 50 cents in this first example. So I need to make sure that is 50 cents greater than 100? No. Is 0.50 greater than 20? Nope, nope, nope. Is it greater than 1? Nope. So I'm not going to use dollars as change for 50 cents. How about here? Is 50 cents greater than 25? Yes. So I know I have to give out quarters starting here. So I need to iterate through all of these all the way down until I hit quarter before I start giving my change. All right. So this is what I'm talking about. So how do I do that? And it's pretty simple. All I have to do is say, look, if change, right? Change is what we owe. If the change is greater than or equal to next dot value. Remember, I'm reducing this global object. I'm using this global object to reduce and stick it into the result. Okay, I'm not actually modifying this global object. I'm creating a new 2D array referencing this money global object. All right, so change. That's why change. That would help. So again, what I'm saying is change greater than or equal to next dot value. And again, whatever my accumulator is, starting at an empty array, take a look at that 50 cents, next dot value. So the next value, all right, dot value means I'm looking at the 100. And again, go with the 50 cents, just like I just said, and you're trying to say 0.50. What is 0.50 greater than? Oh, 0.50 is greater than 25. That's going to let me trigger and say, okay, I need to start giving back quarters. And I know that the index number here, all right, is also going to line up with the index number in my till, all right, or my cash in drawer, I should say, not my till, but the cash in drawer. Oh, cool. Check that out. That all makes sense now. So let's go on to that next step. Now I know my index numbers will match up and I can start decrementing. All right. I know right now I need to take a look at this current value. So I need to know what the current value is as I'm subtracting money from the change. So I'm just going to call it current value. So var current value. And I'm going to set that equal to 0.0. All right, again, it's not an integer. All right, it's a decimal number. And then we're going to do that fancy math I showed you before with math.round. So I have this. And now I'm just going to loop down, all right, using a while loop, all right, to try to find these values, right? So I'm going to use a while loop and do some math, which is, started at 50 cents, give them 25 cents, give them another 25 cents, and take a look at this current value and compare it with the change. So you need a while, all right, and then we're going to say while change is greater than or equal to, again. So as long as I'm going to keep doing this while that change, that 25, that change is greater than or equal to, like that quarter in my example. All right, equal to next dot value, right? And double ampersand. I'm going to start comparing with the cache in the drawer. The cache in the drawer. And again, I can access this index. All right. So the cache in drawer. All right. So that means I'm going to look at what I have here, then index. So the index at this point of that next value is going to be 0, 1, 2, 3, 4, 5. So index 5. So that means I'm going to go over to my cache in drawer 2D array index 5, which means I'm here now, but I don't want this whole subarray. I just want this value, right? So how do I access that value? So now I have cache in drawer index, and I want it's a 2D array, right? And I want the first position of that array. So here I am at quarter, and not the 0th, but I want the first position of the array because that is the decimal that I want to do fancy math with. All right, so I want to take a look at that value and make sure that value, all right, make sure there's enough of those, all right, to actually do math with. So remember what I told you before, that if I actually only had 1/4, I'd have to go down to dimes. So after I decrement that value, I need to go down to the next value. So move on. So as long as we have enough quarters, so while we still have enough quarters, hence the while loop, current value. Oh man, this video is already getting longer than I was hoping. Sorry, guys. Plus equals next dot value. All right. So I'm going to keep adding up to see if that equals the change. Okay. So here we go. So the current value equals the next dot value. All right, which is good. So that's in my placeholder, but that means I need to take a quarter out of that drawer. All right. So in order to take that money out of that drawer, that's my current value equals my next dot value, and then my change, all right, is going to minus equal next dot value. Okay. So here we go. Let's see here. Next dot value. All right, minus that value. Okay, there we go. There's the problem. So I have a current value, which is 0. All right, and here I am taking a look at my new array. I'm going to be using this value to push the new array. All right, and here we go on my cache in drawer, which I am then decrementing based on this value. So I have the value, I subtracted this. So I subtracted a quarter from my quarters, and I added a quarter into my current value. Okay, and I'm going to keep doing that until there's no more cache in drawer. All right, and then once that's no longer the case, all right, it's going to go through, and reduce is going to move on to the next thing. All right, and the next thing after I run out of quarters, all right, it's going to go through and jump down to here, and then start doing that same process to the 10s, the 5s, the 1s, so on and so forth. All right, just like that same logic that I showed you, and we're going to accomplish that with this. All right, now we have an issue. We have this weird JavaScript math that kept throwing errors. So I need to take my change, not my change. See how I'm rushing here? Math.round. And this is what I showed you previously, where we're going to take our change. Why do I keep doing that? I didn't learn how to type today. I'm going to multiply it by 100. Then after that's done, I'm just going to redivide that by 100. That's going to give us our 2 decimal places that we want accurately. It's going to give us our proper rounding, so we don't get any funny numbers. All right. And then let's not forget to take that cache in drawer and subtract that stuff from the cash in the drawer, right? So I've already subtracted it from change, which is what I owe them. I've pushed that value to the current value, which I know I'm going to give them back. But now let's adjust the total cash in drawer. Let's not forget to do that. All right, because we actually gave them money. And remember, the total cash in drawer was this expression up here with the index and the 1 again. So index that we use, 1 to grab the actual amount there. And again, that's going to be a minus equals, all right? And again, just using that next dot value. So that's that while. That's going to keep doing that math until it has to jump down to the next denomination. All right. Now, after it goes through and finishes one denomination, remember that denomination is going to start at the greatest here and then go down into the smallest. All right. And notice that in our return here, it starts from large to small, which is good, which means they expected us to reverse the cash in drawer, which is good. So since that is correct, we don't have to flip that again, which is nice. All we have to do is say, take this accumulator here, all right, whatever that total amount is, and then I'm going to push. All right, so that's 2 dots, of course. What exactly do I want to push into this current value here? Or into our result, rather, sorry. What do I want to push into this result array? All right, so I want to give the denomination string, comma, all right, the total value that I gave them, okay, which is this current value of that, okay? Remember the current value was like 50 cents for 2 quarters, all right? So I need to push current value, okay, and the name of the string into this new array each time I do this, each iteration of this. Because remember, this reduce is going to apply this entire function to each one of these denominations here, all right? Each one of these objects in my global object that is now a local object called result, all right, that I'm copying into it. So I want to take this and I want the next, okay, which is this, name. Now I can take next.name, or I could use this cash in drawer index 0 if I wanted.
And Maven Taurus, please call extension 3000. And Maven Taurus, please call extension 3000.
All right, sorry about that. More interruptions. And I need the actual number, the amount, which is stored in current value. And again, all of this happens for each one of these objects in that money. All right, so I keep scrolling up. All right, so I pushed it, which is good to go. And then I just need to, don't forget, you have to return out of your function. So what I want to return, I want to return my accumulator. All right, so I've pushed this value into my accumulator, and then I remembered to return my accumulator. All right, what happens if this change is greater than or equal to the current value? All right, which means that means you go inside and do that. If it's not, so like the 100, you got to remember that you want to skip over these 120. You don't want to do any of this math. Remember we said if, so it's going to keep bouncing down. So let's just make sure we have this else on here to make sure that we skip else return accumulator. So this return accumulator means that the 50 cents, like we use in this example, is not greater than 100. So just return that empty accumulator. It's not bigger than 20. Return that empty accumulator. Okay, that's what this is doing. Whereas here we're pushing that value to the accumulator. Okay, and then we're returning it. All right, so it's going to be like quarter, 50 cents. All right, and so now we have everything that we need here. All right, so that's for the reduce. All right, that helps us here, but now we have to remember that we need a return for this total function. So that's great. So now we have this stuff returned in result, right? So we have to remember to take this result and return that back out of the function. However, we could have an issue. All right. What happens if there's not enough denomination needed? All right. So let's just say we're gonna keep iterating through, and we could end up with a situation where we need to give somebody, even though we have enough cash in drawer here. All right. What happens if we only have $100 bill and we need to give 50 cents? All right. Well, right now we checked and said, okay, it's not insufficient funds. It doesn't equal, so it's not closed. We're still going to iterate through all of this stuff, and we're just going to return an empty array and give them nothing. Well, that's not good enough. We need to do a simple check. So let's take the results.length and say that if that happens and we don't have enough of a small enough denomination, we're going to return an array with a 2D array with the length of 0 because I have nothing in it. So let's just say the result.length, if that is greater than 0, okay, only if it's greater than 0. All right. And the change is equal to 0, right? Because the change, we don't want to have anything left in the change. All right, so we got to make sure that the result.length is 0. All right, but what happens if we give $100 bill and then or like a 5, and then we don't have enough of this change and we still owe them 5 cents, right? That means as we're decrementing that change value is never going to it's never going to hit 0. So we're going to make sure that change value hits 0. All right. And remember, we can do this in shorthand, which is nice, which means if that's true, we're going to return just the result. All right. Otherwise, we fail that test and we want to return this insufficient funds. And I'm not going to type it in case I'm an idiot and misspell it. And then that'll be embarrassing. Return insufficient funds. Again, this is the shorthand for the if statement if you don't remember. I want to make sure the change is 0, and I want to make sure there's something in that array. All right? I want to make sure there's something in that array. And so return the result if that's the case. Otherwise, return insufficient funds. Even though there's enough in the drawer, we might not have enough of that denominator.